Hello and welcome back. In the previous lectures you learned how to transform entities in a frame using the position, rotation and scale components. In this lecture we are going to talk about how to apply textures to 3D objects in your scene to achieve more appearance than a flat color, and how to further improve them by adding some material properties. Here in our scene I've created two boxes with a width, height and depth of 4 meters each. And the textures that I'm going to use for this lecture are from textures.com, where you can sign up for free and download up to 15 textures per day. I'm also taking this occasion to remember that all the links that I use during the course, as well as the source code for the lectures, are available for you in the resources section of this A-frame course. Okay, let's start with a light blue box. So I add the search attribute just like I would with a normal image element. And then I choose this metal texture that I have already saved in a dedicated folder. As you can see from the image preview in brackets, the light blue color is getting blended in with the texture, so I'll set the box color back to its default material color, that is white. Alternatively, I could also remove the color attribute, but for the sake of clarity in this lecture, I'm going to leave it there as a reminder. And once applied to an object, you can repeat a texture in the X and Y-axis direction using the repeat attribute that has a default value of 1 for both the axes. So now we have 2 columns on each face, and if I change the X value to 2 in example and reload the page, we get this result, as indeed the texture is repeated twice. Anyway, I don't need to do this with this object, so I'll undo the changes and reload the page again. The texture looks okay, but is still too flat due to the flat surface of the cube, and using a cube with a higher number of polygons to reproduce all these depth details would result in a bigger file and consume a lot of memory. So the same way 3D artists do when creating assets for video games, we can create the illusion of depth detail using a normal map. For those who have never heard of normal maps, I can say that they are images that use RGB information corresponding directly with the X, Y and Z axis in the 3D space to tell a 3D application how the polygon should be shaded. And here you can see an example of what a normal map looks like, and the red, green and blue information. And below you can see the result after being applied to a cube. So back to a live preview, I'm going to add to our box the normal map attribute. But this time I'm not filling the HTML attribute with an image URL as I did with the image texture. And instead I'm going to use the A-frame's asset management system. Just let me add a comment first. That whenever you need to render images, videos or models in your scene, as its name suggests, allows you to preload and cache the assets for better performance. And to do this, I add the A-assets element to the scene. Then under A-assets, I define the texture as an image and give it an HTML ID. And fill the search attribute with the image URL of the normal map that I have already saved to a dedicated folder. So in this way A-frame will make sure all the assets are fetched before rendering. I copy the ID metal normal, and now I can reference the normal map using the ID in DOM selector format, so dash. And before I paste the ID, you can keep an eye on the live preview to see how the box appearance will change. There. Now, to repeat a normal map, you can use the normal, texture, repeat attribute, that I'm leaving at its default values for both the X and Y axis, because I didn't repeat the image texture for our box. And then, most importantly, I add the normal scale attribute, and again the default value of 1 for both the X and Y axis, that you can use to change the effect of the normal map in the X and Y directions. And if I move closer, you can see that we actually need to do this, as it looks like that the light source is placed below the box. So if I set the Y-axis to a negative value, I'll be able to create an illusion of depth detail on the surface, as if the light is coming from above the box. You can keep an eye on the box to compare the before and after from 1 to -1, and now it looks much better. And also here you can see how the material scatters the reflected light. And this is something that we can control with the roughness attribute, that by default is set to 0.5. So in example, if I decrease the value to 0.3, the material will look smoother, and vice versa, it will look rougher at 0.7. But I'm going to set it back to its default value. Well, now our box really looks like a container, and we gave it this appearance with a series of HTML attributes like what color to blend in with the texture, an image texture for a specific type of metal, so corrugated plates in this case, a normal map for depth detail, and roughness to control how the reflected light is scattered. And doing so, we actually defined a series of properties of the A-frame's material component. So if I now move on to the brown box, I can repeat the same process in a different way. First, I copy the hex color and delete the color attribute. Then I attach the material component and fill it with the color property and its value, which gives us exactly the same result. And I'm also going to add all the other properties that we defined for our metal box. So first, I include the assets for the brown box in the asset management system. The texture is going to be a brick texture. And then I add the normal map as well. And now I fill the component with the properties that have to be separated by a semicolon. So I refer to the image texture using the ID in the DOM selector format, so -brick, and set the material color to white for the color not to get blended in with the texture. Then I repeat the texture 2 times on both the Y and X axis, and I reload the page. I refer to the normal map, using its ID again. And as you can see, the normal map is not properly displayed, and we need to repeat it 2 times on both the axes, because this is what we did with the image texture. So I add the normal texture repeat property and set its values to 2. And now if I reload the page, it looks okay. But we still need to adjust the direction of the normal map. So I add the normal scale property and set a negative value for the y-axis. And again, you can keep an eye on the live preview to see the before and after. And now the illusion of depth is consistent with the direction that we set for the metal box, as if the light source is placed above the two boxes. Finally, we need to adjust the roughness of the material because it looks too glossy. So let's say 0.9. And if we have a look at our boxes and compare them, well, they look great. I'll reload the page. And it's time to put to practice what you learned in the previous lecture about reflection. So I'm going to attach the scale component to both our boxes. And when I change the x-axis value to -1, I get this particular visual effect. Our boxes have just been turned into two rooms, and when you move around you can look into them from any side. And this looks cool to me. So I update their comments. And before concluding this lecture, I'm going to show you a few more interesting properties of the material component. Just let me add two extra primitives to our scene, and I'll start with a blue sphere. So I add the asphere primitive, to which I attach the material component and color property with a blue color value. And the sphere is now here at its default position. I'm going to place it inside the metal box, and to do so I can copy its position component and values and paste them to the asphere primitive. There. And then I change its radius default values from 1 to 0.5. Now I create a copy of the blue sphere that I'll move inside the brick room. So I set a value of 2 in the x-axis value of the position component, and then I give the sphere a red color. I update its comment. And so, as you know by now, to make the sphere surface look smooth and glossy, you need to set a low value for the roughness material property. 0.2, and I do the same for the red sphere. Well, they may be just simple spheres, but they look beautiful. And this is possible because the roughness is a property of the standard material in a frame that is set by default by the shader property. Which also allows you to use a flat material as an alternative to the standard one. Let me update the comments before moving around our scene. And as you can see, the flat material is not affected by the scene's lighting condition, which is something quite important in other situations that we will see in the next lectures. Anyway, the flat material still allows you to define some other useful material properties like the opacity, which by default is set to 1, and that you can change to adjust the extent of color transparency, so let's say 0.5. So this is how you can apply image textures in a frame and use them in combination with other properties of the material component to achieve better results for the 3D objects in your custom scenes, and I'll see you in the next lecture.